welcome back to my channel. Today I'm going to be talking about properties of groups and subgroups in discrete mathematics. So let's get started. So now let's know what it is properly. So in discrete mathematics, a group is a set equipped with a binary operation. So it has a binary operation, whether it's a plus or a multiplication or anything, and it satisfies all four properties being closure, associative, identity, and inverse law. So if it satisfies these four, then it's called a group. A subgroup of a group is a subset that forms a group under the same binary operation. So the subgroup of a group is called like a subset of that group, and it follows the same binary operation. There's no different binary operation for it. So groups and subgroups play a crucial role in various areas of mathematics, including algebra and cryptography. So now let's see, what is this closure property first. So the closure property states that the result of applying the binary operation on any two elements in the group is also the element of the group. So for example, I take two numbers 1 and 2 and I say the binary operation is plus. I do 1 plus 2, that is 3, and if the 3 belongs to the same group, then it satisfies the closure property. So here it is. In other words, for all a comma b in the group G, the operation A, or like here you can see the a plus b equals r. So you have an operation for that b is also in G. So you have the a b in the group, and the resultant value is also in the group. Only then it's called a closure property. Now let's see the associative property. The associative property states that the grouping of operations does not affect the result, or as we know since our lower standards, a plus bracket of b plus c is equal to a bracket of a plus b plus c, or you can see the multiplication as you can see here. So what is, if this condition is satisfied, then as simple, the associative property applies to the group. So if it is a group, associative property must be true, closure property also must be true. Now let's see the identity element. The identity element, denoted as E usually, is an element of a group such that you multiply E with an element A, multiply or add or whatever you do with A, you do the binary operation with A, your returning answer is going to be the A value itself, that is A itself. Only then it is called an identity element. So now we'll see the inverse element. So inverse element is such that you have an value A, you multiply something to it such that you get the identity element back. So in terms of plus, you can say the identity element is 0, because you have a value A and A plus 0 is A itself. So it's an identity element. Now we have for A, now you are doing addition. So if you want the find the inverse element, you have to do something such that your returning value is the identity element. So identity element 0 is 0, right? Our value is A. If you take the second value as minus A minus A will get cancelled and you'll have 0, which is the identity element. That's how it works. Now, so you understood that, right? So group is something that follows closure property, associative property, identity property, and inverse property. If these four are satisfied, then it's called a group. Now subgroups definition. A subgroup of H, or a subgroup H of another group G is a non-empty subset. Okay, is a non-empty subset of G, meaning it's not empty, and that that itself as a group is under the main operation. So like I said before, the operations performed on the main group is the same operation followed by the subgroup. Now this subgroup H must satisfy closure, associative, identity and inverse property within itself. Like I said, if it is a group, it has to satisfy these. So if it is a subgroup, it also has to satisfy all these. So subgroups can be proper, like it can strictly be smaller than G, or it also can be improper, that is equal to G, exactly same. So now let's see the subgroup criterion. The subgroup criterion states that a non-empty subset H of a group G is a subgroup if and only if the A comma B in H is the product of A. That is, it is a subgroup. The subgroup criterion says that this non-empty subset H, which is not empty and is a subset of G, is a subgroup if and only if for all any value for A and B in H, when you multiply A and B, you should get back A. Only then it is going to satisfy the subgroup criterion. This criterion ensures that the subgroup is closed under the inverses. So that is why it is like that. So here you can see an example how it is going to be of for example of subgroups. In the group of integers under addition, the set of even integers forms a subgroup. Okay. Now in the group of non-zero rational numbers over here, if you see, if imagine it, if you take a group of non-zero rational numbers under multiplication, the set of positive rational numbers forms a subgroup. In the other one, in the group of invertible 2 cross 2 matrices under the matrix multiplication, the set of diagonal matrix forms a subgroup. These are some of the examples for it. Now, properties of subgroup be like, the subgroups inherit the properties from their parent group, including closure, associativity, identity, and inverse law. The intersection of two subgroups of a group is also a subgroup. The union of two subgroups is generally not a subgroup unless one subgroup is contained within the other. And so let's see the conclusion, that is groups and subgroups are the fundamental concepts in discrete mathematics with applications and in different various fields. You can see here mathematics and its branches. You can see where and all it goes, the different branches in mathematics. So one of them, it comes here, that is going to be your groups and subgroups. So understanding the properties of the groups and subgroups is essential for studying the algebraic structures and solving mathematical problems. Further, the exploration of groups and subgroups can lead to advanced topics such as the group homomorphism and group actions. So it's interconnected. You have many more subjects that come in. So this was my short video on groups and subgroups. Hope you understood something. Thank you.